So here's, there we go. So here's a sort of a smattering of what you wrote for the quadratic formula. If we want to solve the equation ax squared plus bx plus c is equal to 0, we can do so by evaluating some expression, and that expression is what we call the quadratic formula. So looking at the responses that you wrote down, what do you see, first of all, what are some common elements that you can see from these 5 different responses? We're at that elephant problem again, right? Where the 5 of you are each sort of feeling a different part of the elephant. One of you has got the trunk, and you're like, oh, it's a snake. One of you has the hind leg, and you're like, it's a tree, right? But really, it's an elephant, and each of you is just feeling a different part of it. So what is it that's in common to the responses up here? What are some of the elements that you see that are shared? The first thing we notice about these responses is that the purpose of the quadratic formula is supposed to let us use nothing more than knowledge of the coefficients a, b, and c to solve the equation ax squared plus bx plus c is equal to 0. And so this right-hand side of the quadratic formula should involve a's, b's, and c's. And only a's, b's, and c's, really, right? There should be no other unknown quantity that we need in order to solve this quadratic equation. So the first thing we see is that they all have a's, b's, and c's. What are some of the common algebra arithmetic features that we see coming up in several different responses? So response 3 and response 5 have a lot of common features. What do they have in common, first of all? Well, one thing I see that they have in common is that they both, and response 2 also shares this, they both frame this formula as a big fraction, right? We've got a big numerator and a slightly less big denominator. So that's one thing that 2, 3, and 5 share. Actually, 4 also has this too, right? All those responses frame this formula as a fraction. What else do 3 and 5 agree upon? So both 3 and 5 also include this big square root, and it's included upstairs in the numerator. So I'm going to agree we want this big square root up in the numerator. And in fact, both 3 and 5 agree on what goes underneath that square root. If you look at it closely, both of them say underneath the square root is this quantity b squared minus 4ac. Okay, so they share that in common. What about the denominator of this big fraction? 2a. Both 3 and 5 seem to agree that the denominator is 2a. So there's a good deal of consensus among those 2 responses. Well, what's different about them? First point of disagreement is that response number 3 begins the numerator up top with b, where response number 5 has a minus sign in front of the b. So that's one of the things that we need to figure out, whether it belongs. What's the other thing that they don't agree on that's different between 3 and 5? So response 3 has something that 5 doesn't. Yeah, it has this plus or minus symbol here. So those are the 2 points of disagreement between response 3 and response 5. And I'm going to give each of the responses 3 and 5 a point, because each of them has a correct piece and an incorrect piece. So I agree with response 5 on the minus sign in front of the b. Beginning of the quadratic formula, and the numerator leads with minus b. But I agree with response 3 that what connects that minus b with the square root of b squared minus 4ac is a plus minus operator in front of it. And so if we look at 3 and 5 and we take their elements that they have in common, which are all correct, and the elements on which they disagree, of which each had one right and one wrong, combine them together, and here we get the quadratic formula. X equals minus b plus minus the square root of b squared minus 4ac all over 2a. And the purpose of this formula is that it solves any equation of quadratic type, as long as this a in the front is not 0, right? Which it wouldn't be if we simplified the equation first. So any equation of quadratic type we can solve with this formula. But unfortunately, that requires you to remember this formula. That's the cost. The cost of using this very powerful tool, because before, we didn't know how to solve one of these equations unless we could factor it. We learned how to factor in Module 7 and Module 8 so that we could solve equations of quadratic type without using a nasty formula. But that limits us to only those equations that we can factor. And not every equation is easy to factor. More than that, not every equation is even possible to factor. That's the bad news. The good news is this formula always works. The bad news is you got to remember the formula. There's a wealth of different resources and mnemonics and songs and memory devices for remembering the quadratic formula out there. I recommend finding one and committing this formula to memory. There are very few things in algebra that are worth memorizing as such. Right? Algebra deals a lot in big ideas and main sort of techniques and processes, and the memorization load is supposed to be pretty small, but this has got to be in it. Because if you come across a quadratic equation that's not possible to factor, this is your only recourse. Well, there's another technique that you might learn in pre-calculus, but we won't go there. This is your only recourse. And there will be a question of this type on the exam. There always has been, and there always will be. So it behooves us, first of all, to remember this formula, but second of all, to get some experience using it.